Hello students, welcome to the course Digital Signal Processing. We are discussing the unit number 2, that is Z transform, and the very important point, that is the properties of the Z transform. So let's see the next property of the Z transform, that is the conjugation. So in the conjugation we are dealing up with the simple factor, that is x star of n will give the Z transform as a x star of Z star. So how it is? Let's see with certain proof. So here we are going to calculate, let's say, the right hand side for this one. So I will just consider this right hand side and will check whether it is giving me the x star of n. So x of z will be given by the expression, that is summation n is equal to minus infinity to plus infinity x of n z raised to minus n. So at this particular step we just calculated the, or applied rather, the definition of the Z transform. So once we apply the definition, let's take its conjugate. So how to take this conjugate? So this will be taken over here with the help of this star. So once we have taken the conjugate, it will become the x star of z. So x star of z means the conjugate of this entire summation. So that is what applied over here. So at this particular stage we can just find out the conjugate means the star is applied to the entire term. So once it is done, so here what is happening, just check in the next step, x star of n, this is what change for this term, and z of minus z raised to minus n, its star means it will result in a positive value of n. So that result will give ultimately the value as a x star of n into z raised to n. So that is nothing but the x star of z only. Now in the next step we are going to just concentrate on x star of z star. So x star of z star means, again I need to just complement the values of z. So x star of n will remain as it is. So z star means here z raised to n raised to star is taken. So once it is taken over here, just observe that this is what the star. Now this star will affect this particular value, that is z raised to plus n. So this z raised to plus n will be changed to the value, that is z raised to minus n. So here we can easily obtain the effect that this is getting changed to minus n. So from plus n, after the application of the star, that is the conjugation, it will be changed to the minus n. Now just observe this entire thing. This is equivalent to that of the definition of the Z transform. So just compare this particular equation with the Z transform. This block I will compare with the Z transform equation. So here I can just sense out that this x star of n is nothing but actually we can represent in this particular formula, that is Z transform of x star of n will give me ultimately x star of z star. So that is what done over here. So that is, in short, we can just say conjugation property. Now let's proceed to the next property, that is nothing but the differentiation. So differentiation, this is what the next property. So in the differentiation we can just concentrate on this highlighted portion again as a reference to our entire discussion. So this is what the reference for our entire discussion. So this property will concentrate that n times x of n will give the z transform as a minus z d by dz of x of z. So to get this, let's proceed to the right hand side. So on the right hand side I can just take one of the example to solve this particular property. Let's say we want the inverse z transform of what? X of z is equal to log 1 plus az inverse, and the ROC is given as a mod z greater than mod a. So let's differentiate to both sides. So how to do it? That is, because we are going to prove here this particular right hand side, that is d by dz of x of z. So x of z is already given to us. So let's find out its differentiation. So d by dz of x of z. So it will give obviously log 1 plus az inverse, means it is log x in short. So its derivative will be what? 1 plus this az inverse. So this is what its derivative, but again we need to obtain the derivative of this particular term, that is az inverse. So its derivative will be minus az raised to minus 2. So once this is done, this entire calculation is calculated for dy dz of x of z, then we can just multiply it by the minus z. So minus z dy dz of x of z, this is representing the right hand side of the equation of differentiation property. So it will result in the equation which is entered over here as a az inverse into 1 upon 1 plus az inverse. Now to compare with the property which is just provided as a shaded portion over here, this property will guide us that a raised to n u of n will give the z transform as a z by z minus a. So if someone assumes here the value of a as a negative, then this will become z by z plus a, and the ROC will be mod z greater than mod a obviously. So by the application of this particular property for the causal sequence, making use of z transform property and ROC, obviously from this equation we can go for the conclusion that is n times x of n. After applying the property, it will be nothing but a into minus a raised to n minus 1 into u of n minus 1. So once we got a n times x of n, which is nothing but shown over here as the left hand side of the differentiation property. So once n times x of n is obtained, so just divide this n to the right hand side, so like here, so as to get what, x of n, which is just provided over here. So this is nothing but the x of n. So this is how we will get the x of n from x of z by the application of the property that is differentiation. So we can conclude here that multiplying the sequence in time domain by n is equivalent to multiplying the sequence, the derivation of its z transform by minus z in the z domain. So this is all about the differentiation property. Let's see one of the chart which will guide you that what are the different properties and related z transform as well as the ROCs. So let's see this chart. This is what one of the chart which will guide you that whatever the properties we have seen till today's lecture, these are simply reflected over here, that is linearity property. Next property which you can just observe here for the linearity, this is what the application, and the ROC which you can just sense out here, that it is at least the intersection of ROCs, ROC1 and ROC2, means x1z, x1 of z and x2 of z. Next property is time shifting, which is we have seen x of n minus k will result in z raised to minus k x of z. Similarly, time reversal, x of minus n will result in x of z inverse. Scaling, a raised to n x of n will result in x of a inverse z or x of z by a, that is one and the same. Just now we have seen conjugation. This is what the conjugation property. Next, real part, imaginary part, even the convolution is quite important. x1 of n star x2 of n or convolution will result in multiplication in z domain. Similarly, here the correlation can be observed. Initial value theorem is also over there. So this is all about some of the properties of the z transform and its table. So this is very important as far as the numericals based on the properties are asked, and we will require all these formulae to solve the numericals based on the inverse z transform. So thank you everyone, thank you very much.